So the topic we are looking into is latitudes and longitudes. Latitudes and longitudes are actually imaginary line that runs around the globe. Here we introduce it by saying that the Earth is spherical in shape, and if you imagine slicing the Earth horizontally and vertically, those horizontal slices can denote the latitudes, while the vertical ones denote what? The longitudes. Now, if you look at this sketch here, you will notice that we have two horizontal imaginary lines that runs around like this in a circular form. Those are the latitudes, while we also have two vertical lines that runs vertically around the globe. These are the longitudes. Okay. Now, where these two, the latitude and longitude meet, gives us the coordinate of the coordinate basically, or the geographical coordinate of a particular point in the globe. You know, in coordinate geometry, we often denote any point in space as xy. Now, when it comes to this particular topic, we will still use the denotation xy, but you should note that x has to do with the angle of what? The latitudes, and y will be that of what? The longitude. So the geographical coordinate has to do with the latitudes and longitudes. Okay, latitudes before the longitudes. Now, if we consider a side view of the Earth, you see that here we have the longitude. Okay, see the vertical lines that are running. Now, if you notice, the dotted line here is called the Greenwich meridians. Okay, this is the line that divides the Earth into two equal halves, from the northern part to the southern part. It divides the Earth into two equal parts. Okay, so the manner in which we measure the longitude is always from degrees north to east, or from degrees north towards west. Okay, north to east, or from south to east or south to west. But often we look at more of north to east or north to west. Now, the side view for the longitude, we see the longitudes are horizontal lines that cut across the globe. These imaginary lines. And if you look at the dotted line here, these are what we call this the equatorial line, and this equator is actually also a great circle. As the longitude, by the way, they are all great circles because they pass through the northern point and the south point. Okay, all the vertical circles that passes through these 2 points are actually great circles, and the latitude here is not excluded. It is the only latitude that is part of the family of great circles. Okay, the other latitudes are not great circles. As you can see, this latitude here is the circle formed by this latitude is less than the circle formed by this latitude. Okay, of which the equatorial imaginary line, which is the latitude, is the largest of all of these latitudes. Okay, we measure the angles from 0 degrees at the equatorial line, 0 degrees to north to 90 degrees north, or from 0 degrees to 90 degrees south. Okay, now look at some examples. Say find the angular distance between point A, 40 degrees north, 65 degrees east, and B, 35 degrees south, 65 degrees east. You can start by making an illustration just to illustrate what you have there in picture form for better understanding. If you look at what we did here, the sketch here, when you construct your circle here, you have your north, you have your south down, you have your east, and you have your west. You notice that from the question, the 2 points A and B lies on the same longitude, okay, 65 degrees east. They are both on 65 degrees east, 65 degrees east. So if we trace the longitude 65 degrees east, this is the Greenwich meridian, this dotted vertical line. So if we trace out, let's assume this is 65 degrees east. Okay, there's the eastern part. Now the first longitude is 40 degrees north. So we have 40 degrees north, and then the other one is what? 35 degrees south. These 2 points where they intersect is A and B respectively, and the angular distance between A and B is therefore what? Is simply the sum of the angles of the latitude, 40 degrees and 35 degrees, which is what? 75 degrees. Now note that when the 2 points, when the 2 points A and B are on the same longitude, as in the example we saw, the same longitude and different latitude, the different sides of the latitude. You know, the latitudes are divided into two. We have the northern latitude and we have the southern latitude. Just as the longitude are into two, so we have the eastern longitude and the western longitude. Those are the two parts. So when the 2 points given A and B are on the same longitude and different latitude, that is, maybe one is on the latitude north, the other one is on the latitude south, what do we do? When this happened, the angular distance is always equal to the sum of the angles of their latitudes. Now when the 2 points are on the same latitude this time around and different longitudes, that is, maybe one is on the longitude east, the other one is on the longitude west. When they're on different longitude, what happens here? We also sum the angles of their longitude. That is, the angular distance will be the sum of the angles of their longitude. The third point is when the 2 points are on the same latitude, when they're on the same latitude and the same longitude. Let's say the 2 points are on the latitude, on the northern latitude, and the 2 points are also on the on the eastern longitude. You see we have 2 eastern longitudes and then one latitude where the 2 points are. In this case, we take the difference of the angles of their their longitude. That is, we have the angular distance is the difference of the angles of their longitude. Like in this sketch you see here, we have 2 longitude east, and on the same latitude. Similarly, when the 2 points are on the same longitude and the same latitude, we do what? We also take the difference. We also take the difference of the angles of of their latitudes. Very important. So now if you are asked to find the angular distance between you have x, which is 60 degrees latitude, 60 degrees north, 20 degrees west, and the point y, which is 40 degrees north latitude and 20 degrees what west. You notice that for this particular problem, there's north or south, they are on the same what longitude. Okay, longitude what west. Here is the east, here is the west, so they are all the same longitude, so we can assume this is 20 degrees. This is 20 degrees longitude west. And we are told that the 2 points are what both on what on the northern hemisphere. So if this is the equatorial line, we are going to have the first point here. This will be 60 degrees north. Then we can say the second point is here, 40 degrees north. Okay, these 2 points where they meet here will be x and y respectively. So we are asked to find the angular distance in the center. We look for the angular distance, the angle between those 2 points. Okay, the angular distance of x and y. Of course, you notice that they are on the same longitude and the same what, and the same part of the latitude. The latitude, that's the northern part. Okay, so what we do here is we just take the difference. The angular distance will now be what? Will be 60 degrees north minus what? 40 degrees north, which is what? 20 degrees north. So that's the angular distance. So let's look at a new subtopic. We have the distance along great what? Circles. Okay, you see the distance along any of the longitudes and along the equator and along the equator only, okay, among what? The other latitudes, among the are called what? Distance along great circles. The distance along any of the latitudes and along the equator only among the other latitudes are called the distance along what? The great circles. Simply because, remember, we said it earlier on that the longitude and the equator are all what? Great circles. So how do we find the distance if we have between 2 points on those great circles? Now we use the very known fact, the length of the arc of a particular circle. The fact is what? The length of arc is what? Length of an arc is often theta all over 360 times 2 pi r, okay, which can also be written as theta all over what? 180 pi r. 2 cancels 360, 180 times, okay. Where r here, now you should be careful. This r here will now denote the radius of the circle. But since we are dealing with main planetary, the globe, the Earth, you should note that often this R, let's use capital R. R here will be the radius of the Earth. Okay, that is R is often 6,400 kilometers. That's the radius of the Earth. Okay, that's what we'll be using throughout. Now, example. Find the distance between you have A, which is 0 degrees south, 30 degrees west, and B, which is 0 degrees south, 60 degrees east. Okay, that's the first point. The second point is P, which is 30 degrees north, 50 degrees west, and Q, which is 30 degrees south, 50 degrees west. These 2 points. We need to find the distance between them. Okay, you must not always sketch, okay? So you can just analyze the points given. You see from the points here we have the same latitude, okay? The same latitude and different longitude. Theta here is actually the angular what? Angular distance. Take note. Okay, theta is always the angular distance. So now let's solve this question. We have angular distance, that's theta, is equal to what? Remember we said when they are on the same latitude, okay, and different longitudes, what happens? We sum what? The angles of the what? Longitude. So we have 30 degrees plus 60 degrees, which is clearly what? 90 degrees. Okay, so we have theta equals to 90 degrees. So the distance between what? Between A and B is what? Theta all over what? 180 times what? Pi what? R. That is 90 over 180 times what? 22 over 7 times 6,400. Okay, which gives us okay, or we have 53.1 kilometers. Okay, any of this. So that's our final solution for the A. Now the B says we should find first the B. We have the 2 points. We have the points P, 30 degrees north, 50 degrees west, and 30 degrees south, 50 degrees west. We see that they are on the same longitude, but what? Different what? Latitude. So as a result, we are going to sum what? The angles of those latitudes. So theta will be what? 30 degrees plus 30 degrees, which is what? 60 degrees. And therefore PQ, which is theta all over 180 times what? Pi R, will give us what? 60 all over 180 times 22 over 7 times 6,400. Okay. Use your calculator. You have exactly 6702.1 kilometers. Okay, kilometers. That is it. So 2.4.2 this time around. Here we have that the distance along small circles. Okay, that is along parallels of latitudes. Okay. Now these are actually any distance along the latitude except what? The equator. Which is what? The equator itself, which is what? Which is a great what? Circle. Okay. Remember, we are looking at the distance along small circles. So we have nothing to do with what? We have nothing to do with great circles here, which is the equator. Okay, so that's why we are excluding the equator. So now if you consider this illustration, okay, let's say there is an equator. Okay, let's say this is the Greenwich meridian. Okay, from here to this point gives us what? The radius of the earth, right? Now if this is the center, let's call it O. This is the north, this is the south, east, and the west. Now let's suppose we have a latitude at 5 degrees north. Okay, that is certain 5 degrees. 5, the symbol. Okay, 5 degrees north. Okay, this is 5 degrees north, where 5 is a certain number. Now at this point we can make the latitude that falls under that particular horizontal. Okay, now this latitude here is the center, as you can see, and this will be what? The radius of what? This small circle for the latitude 5 degrees north. Okay, now I hope you believe with me that the angle here is equivalent to phi. They are the same, alternate angles are equal. And of course, if I call the center of this small circle P, okay, you see that we have a triangle PO, and then if I call this point let's say X, POX gives us a right angle triangle. Okay, we have a right angle triangle there. So how are we going to say it? So let me say, suppose X is a what? Is a point on the earth surface. okay, with latitude 5 degrees what north. Then if I call this y, okay, then xy is what? It's a small circle, okay, with radius small letter r, okay, small letter r, and you see that from the triangle OPX, okay, from the triangle OPX we have here is for POX, so this angle is phi, this is the radius there, of course this would be the radius of the earth. Why? Because the distance from the center to the surface of the earth is often what? Same thing as the radius of the earth, just as the distance from here to here is r, okay. So we have this, see this is a right angle triangle. So from here we see clearly that what? We see clearly that the cosine of phi is equals to what? Small letter r over capital letter R. Or we have that the radius of that small circle is equals to r, the cosine of phi. Okay? Very, very important. Very important. We are going to use this a lot. So what are we saying in essence? We are saying that when calculating what? The distance of any 2 points, okay, on a small circle, that we use, of course, the formula for distance is what? Equals to theta over what? 180 times what? Pi r, okay, where r here is equals to what? Our cosine of phi, okay. That is, we are saying that the distance, what we use is distance is equals to theta, okay, over 180 times pi r cosine of phi. This is what we're going to use. Of course, theta is always the angular distance of the points. The angular distance of the points. Where phi is what? Phi is the angle between the given parallel of the latitude and the equator. Phi is the what? The angle between what? The given small circle and what? The equator. Okay? Okay. So we have two towns A and B on the same parallel of latitude 60 degrees south, and their longitudes are respectively 35 degrees and 155 degrees. And we asked to find the distance between A and B along the small circles, that's the parallel of the latitude. Okay, you guys know I like sketching. Let's say this is north, south, but you must not. If you want to save time, you can skip that. Let's say that's the north and south, and then we have they are both, the 2 points are, we are told that they are on the same latitude, 60 degrees south. Let's say this is the equatorial line, 60 degrees south. So this is 60 degrees south, okay, and they are on the longitude. One is at this is the Greenwich. One is at 35 degrees east. So this is 35 degrees, and then let's say this other point is what, 155 degrees, both in the east. So we're looking at these 2 points here, okay. So the first point, of course, this is town A, this is town B, okay. We're looking for this. We need now, for this circle we have for this small circle, here is the center, yes, P. So we are looking at the distance between, well, we first of all need to find the distance between the center P here and any of these points A or B. That's the radius. So how do we do that? If you recall, we saw earlier on that the radius of the small circle R is what? That of the earth times what? The cosine of phi. Okay. Now in this case, phi is, remember, the phi is the angle between what? Between the small circle, that's the parallel of latitude, and the equator. And that angle is 60 degrees, okay? From here to this parallel, the angle between this and the parallel of latitude, than the equator, 60 degrees. So we have 6,400 cosine of what? 60, okay? Now the distance AB will clearly be what? Theta all over what? 180 times what? Equal, that's pi half cosine of phi, right? What does that give us? That gives us then of course, what is theta? Theta is what? The angle between, theta is the angular distance between A and B. Now you notice the 2 points are on the same what? Latitude, and on the same side of the longitude. So what we do, we take the difference. So we have 155 minus what? Minus 35, okay, giving us 120 degrees. So AB is 120 over 180 times what? Pi times 6,400, the cosine of what? 60 degrees. All this using our calculator give us consider that, of which we have the equator here. Okay, because this will be the radius of the Earth. Now, if you consider a latitude of 5 degrees, 5 degrees north, at this point we'll have a circle, a small circle. Okay, so suppose this is the center of this circle, let's call it P. Okay, and then we consider two great longitudes. So longitude to the north is here, so we have another. Okay, so we are looking at these 2 points basically. Now the distance from the center of this small circle to this longitude is small letter r. Same thing here, small letter r. Okay, now the distance from this point here, if I call this point A and this point B, the distance from this point A straight to the point B, okay, will be AB. If you see, if I pull out APQ, okay, so from the illustration, the sector APB is what? We have AB here, we have P here. Okay. Now the angle between those 2 points, will be what? The angular what? The angular distance. Okay. The angle between here will be the angular distance, which is theta. Now, if I bisect this angle into 2 equal halves, so we'll have this side to be equal to this side, okay? And this angle will then be theta all over 2. Same thing here, theta all over 2. So we are going to have sine theta over 2 is equal to the opposite, which is what? Half of what? AB all over what? The hypotenuse, which is r. Okay, or you see clearly that what? R sine what? Theta all over 2 is equals what? AB all over 2. So AB, which is the shortest distance between those 2 points, is the distance AB is the distance of the chord. will be 2r sine theta all over 2. Okay, now to determine the distance, okay, the distance along the great circle, of the 2 points on that small circle. We are going to use this AB. How? Now, what that is like, let me try to sketch it again. Okay, I said there is the longitude where those 2 points were located. We have A and B. We had A and B. Okay, if you recall, we said the equator was somewhere here with the center O here. Okay, now we are looking for the great circle that will pass through A and B. And that great circle, if you think of the circle, if you think of the great circle that will pass through A and B, I will illustrate that. Imagine a great circle that runs around the globe in this direction. It runs like this. This is the point A. Okay, that great circle, we will need this distance it makes, this distance covered along this great circle, where this is the center, of course, this is the radius, okay, the radius of the earth, from the center to the radius of the earth. This arc is the distance we are looking for along this great circle, the great circle. So you see that we also have a sector here. We also have a, so we can say from the sector OAB, the sector OAB is actually like this. Of course, the radius of the earth. Now, clearly, we know already what is AB. AB is still what we obtained earlier on. Now, the angle here, this time around, the angle here from the center, the angle at the center, we're going to call it alpha. So if you split that angle into 2, this will be alpha all over 2. Same thing here, alpha over 2. 90 degrees. This side will be equivalent to this side. And because we know already AB, we can easily find this arc. Okay, that is you see that sine alpha over 2 is what? Sine alpha over 2 is the opposite, which is what? Half of what? AB all over the hypotenuse, which is capital letter R. Okay, if you do the cross multiplication, no, we don't even need it. We need to find the angle. Okay, so we don't need to cross multiply. All we just have to do is what? Take the sine inverse. We see that alpha all over 2 is equals to the sine inverse of what? AB all over what? 2R. Okay, that is alpha is equals to the sine inverse of AB over 2r. Good. So that is alpha. Now the distance along this arc, okay, so the distance along that great circle is what? That's AB. That's sorry, distance is equal to this angle here, theta, all over what? Alpha, I mean, over 180 times what? Pi what? Pi what? Pi that's obviously the formula for the length of the arc, this arc AB, okay, theta alpha all over 180 times pi r, the radius. Now the question is, what is alpha? But we have shown that alpha is what? So the sine inverse of what? AB all over what? 2r, which is equals to the sine inverse of what? Of course, we have also shown that AB is equals to what? 2r sine what? Sine theta all over 2. Okay, 2 cancels 2, so we have 2 the sine inverse of what? R over calculator r sine what? Theta all over 2. Now but r here is the radius of what? That small circle, the small circle for that particular where is it? R here, that's this small circle here, the radius here, and we have shown already that it is equals to what? R what? Cosine of phi. Okay, we proved that earlier. So when we do the replacement, you see that alpha is equals to 2 the sine inverse of what? R cosine of phi over R sine what? Theta over 2. This cancels this, so therefore we have alpha is equals to what? 2 the sine inverse of what? Cosine of phi, the sine of what? Theta over 2. Okay, hence the distance along great circle is what? Is equals to alpha over 180 times what? Pi r, which is equals to what? 2 sine inverse of cosine of phi sine of theta over 2 times pi times r all over what? Okay, yes, over 180 degrees, which is the same thing as what? Sine inverse of the cosine of phi sine of theta over 2 pi r over 90 degrees. 2 goes here 90 times. Okay, so In conclusion, the distance along great circle is what? Will always be pi r times the sine inverse of the cosine of phi, the sine of theta over 2, okay, divided by 90. So we have 2 points P and Q on latitude 55 degrees north and the longitude 34 degrees west and 25 degrees east respectively. We need to find the distance between them along 1, the parallel of latitude, and then along the great circles. Now, so if I make a small sketch here, we have our north, south, east, west. We have that the 2 points are on what? The same longitude, 90 degrees what? 55 degrees north, okay? So let's say this is 55 degrees what? North. And they are on the different latitudes. One is 34 degrees west, and the other one is 25 degrees east. So we are looking at these 2 points, okay? This is P and this is Q. Now if here is the equator, okay, and the meridian, the angle from the equator to this point, that angle is phi, and it is 55, okay? From here we see that phi is what? 55 degrees, the angle of the latitude, and the angular distance theta, these 2 points are on the different sides of, they have the same latitude and on the different parts of what the longitude. So as a result, we add the angles of the longitude, I mean. So we have 34 plus 25, which gives us 59 degrees, okay? Now the distance that's along the small circle We know the distance is equal to what? Theta over 180 times what? Pi r, the cosine of phi. Okay, that is, we have 59 times what? Pi times 6400 times the cosine of what? 55 degrees. All of this over 180. So this gives us kilometers. Now, for the distance along the great circle, okay, formula is what? Distance is equal to pi times the radius of the earth, the sine inverse of what? The cosine of phi, the sine of theta over 2. All this divided by what? 90. So we have pi times 6400 times the sine inverse of the cosine of 55 times the sine of 59 over 2 divided by 90. So we have